Welcome to the distance learning program presented by Innobus on Enterprise Java Beans. So Enterprise Java Beans are all about POJO plus annotation is equal to EJB. It means it is simple plain old Java object combined with annotations will give you easy development of enterprise application through EJB Bean. We'll see what is EJB. EJB is nothing but an enterprise Java bean, which is a server-side component model of the Java platform for developing distributed enterprise applications. It enables enterprise develop secure, scalable, multi-platform, business-critical applications as server-side components. The EJB specification is part of Java EE specification, which is nothing but Enterprise Edition and encapsulates the business logic of an application. Applications are deployed using EJB, run on Java EE application servers, which include an EJB container by default. So, EJB will run on Java EE application servers, which contain EJB container, and therefore standalone EJB container can also be used. The main point of EJB was to allow enterprise developers to concentrate on business logic and free them from the need to write transaction, security, caching, pooling, and threading. These are all some of the tasks which EJB container will do by itself. So these are all done, and even apart from these, there are many more services provided by container to perform the task for EJB beans. Enterprise beans are widely used for developing large and distributed applications. Types of enterprise beans: session beans and message-driven bean. Session beans. What are session beans? We'll see those. A session bean implements and encapsulates a business task that can be invoked programmatically by a client. Client can be a browser or any other client, or a local, remote, or web service client views. The session bean performs work, can be like calculations or database access or any business logic for its client, shielding it from complexity by executing business tasks inside the server. The EJB container manages the life cycle of the session bean instances and also destroys session beans of its client when it is timeout. So this is the basic session bean in a three-tier architecture, where we have the browser or mobile phones or PDAs, all these devices accessing web applications through web container and EJB container, which runs on application server, which in turn access database for any kind of data. So this is where session bean will be located in EJB container for getting its task done. So therefore, how it works is, when the end user launches the client application from his desktop, enters some data, and then he'll trigger some event by entering the data. By then, when he clicks on any event button, the general workflow will follow as user action establish a connection to the session bean running in the EJB container, which in turn runs inside the application server using RMI, which is remote method invocation, after which the client application invokes one or more business methods inside the session bean. The session bean processes the request and validates data by interacting with database, enterprise applications, legacy system, and many more. The session bean finally sends a response back to the client application either through a data collection or simple objects that contain acknowledgement messages. So this was the simple session beans in a three-tier architecture which performs the task inside EJB container. We have types of session beans. We have stateless session beans, stateful session beans, and recently in EJB 3.1 onwards, we also got included singleton session beans. So in each, we have annotations also to be coded for, which makes development very easy with plain old Java objects. We'll see more in detail all these types of session bean. So when do you use session beans? We got to know what are session beans. When we'll use was if there is only one client when it is accessing the beans instance at a given time, then you have to go for session beans. When the bean is not persistent, that means the bean is going to be existing no longer. The bean is implementing the web services. All those were the reason or the requirement when you want to go for session beans. And as we have discussed, there are three types of session bean. One among, to begin with, stateless session beans. Stateless session beans provide a single-use service. They do not maintain state on behalf of the client because the name itself says it's a stateless session bean. They are relative, which means they are very short-lived. EJB container destroys a stateless session beans once its task is performed. Any two instances of the same stateless session EJB type are always identical. Each instance can be shared by multiple clients. Support multiple clients and therefore provide better scalability for applications that require large numbers of clients. A stateless session bean is annotated with @stateless. When to use stateless session beans? Whenever bean does not contain the data for a specific client, if there is only one method invocation among all the clients to perform the generic task. So we'll go and see the life cycle of stateless session bean. This is the picture which represents the life cycle of session bean, that is stateless session bean. So a stateless session bean instance starts when the container invokes a new instance method on the session bean to create a new session bean. The container performs any dependency injection as specified by metadata annotations on the bean class or can be through deployment descriptor. The container then calls post-contract lifecycle callback interceptor methods for the bean, if any, and the container can perform the instance creation at any time. Therefore, the session bean instance is now ready to delegate a business method call from client or a call from container to a timeout callback method. When the container no longer needs the instance, the container invokes pre-destroyed lifecycle callback interceptor method for it to end the bean lifecycle. Post-construct lifecycle method used to mark a method defined in the bean class so that the container can invoke that mark method just after the creation of stateless session bean instance and dependency injection of any resources. This callback can be used by the initialize any resource such as database connection, files, etc. So this post context can be used for these purpose. At pre-destroy used to make a method defined in the bean class so that the container can invoke that mark method before the stateless session bean is destroyed. This callback can be used to release any resources, can be closing the connection or any other such bean. Therefore, this is a basic lifecycle method which will involve all these in it. And the container also does task of creating bean instance, handling the dependency injection. Dependency injection, it can come through the injection of beans within the class if you want to inject any bean, any other bean within the current bean. So there the dependency injection concept comes into picture. Then finally container calls at post contract, or it also calls pre-destroy. Let's see the project setup for EJB along with stateless session bean demonstration. So we'll do the EJB project setup in Eclipse, and the server is WebLogic. You need to have application server to run your EJBs. So here we are using WebLogic as an application server. So to begin with, you need to create an enterprise application project. EJB is all about enterprise application. So let's create enterprise application project. Once you select enterprise application project, it will create an EAR application, which is nothing but enterprise active application. Now project name, let's give as EAP, which tells enterprise application project, and then finish. So if you see, we are using Oracle as an application server, that is Oracle WebLogic application server. So for running your EJBs, you need to have application server, which is WebLogic here. And once you are created with this, you get the structure and select the same folder and now create new EJB project. Here if you see there is an EJB project, click on that and you get EJB project wizard. Give an EJB project as EJB project. So once you are done with this, we have the server as a target runtime, and here EAR membership. We already have created it. So select that project which we have already done, that is enterprise application project. You need to add that to an EAR because this is an EJB project which needs to be added to this EAR. And once you are done with that, you just click finish. See, if you create EJB project, it will also create an EJB project client. This will act as the client for your EJB project. So now we need to create a stateless session bean. So this is the basic project setup where you have to create an enterprise application project within which you will create your EJB project. So once you have created EJB project, it will create you one more folder having EJB client. So we need to have this because in this client we will have all our remote interfaces. Now I'll show you how is that. Let's create a stateless session bean within this EJB module, that is within EJB project. Create a new session bean. If you see here, there is an option to create new session bean. Just select here, give the package as com.innobus. So class name you can give stateless session bean. So since we are creating stateless session bean, so we can give class name as that. You class name and package name depends on your naming convention. So in this, we have already given this. Now, the major thing here to look into is create business interface. To talk about business interface, all about EJB is remote method invocation. It means you will access the beans which we are talking till now. The session bean, stateless session bean, and still many other types like stateful, singleton. So all these EJB beans will be deployed in the server, and we will go and access or use that bean only through these business interfaces. These interfaces will have the declaration of the methods being defined in the actual beans which are present in your server. So how can we connect to that bean? It is only through these business interfaces. Now if you see, there are two business interfaces here. One is remote, one is local. Local will indicate that if your bean is within your same system, and if it is remote, it is in different system. So especially for distributed application, and EJB is all about distributed application. So here you can select this in order to see that you are working within the same system. But since EJB concept says it is remote interface, that is remote invocation which can be accessed, EJB beans is all about that. So let's try and select remote. And once you are selecting remote, just click finish. So it will create a stateless session bean with annotation stateless. We have seen this, that stateless session beans will be annotated with stateless. And if you see this, it is implementing stateless session bean remote interface. This is nothing but the simple Pojo. If you see here, the project client has got that interface. It is a normal Pojo, but the wizard has created us for, by default, the remote interface from which you can access the bean. So if you see, all the remote interface will be present in this client project. So this client project has been created by default when we created EJB project. The reason being, this client project will be with the client side. So this EJB project will go to your server side. So when you deploy, you basically deploy this. So to access, you have all the remote interfaces present within the client. So this is the basic knowledge of your EJB project setup. So whenever you have the interface, and if you are noticing, everything is Pojo. In EJB, everything is Pojo. We are not extending or implementing any interface. This is the interface from which we are trying to access our status session B. And here, let's create, to demonstrate, a method. Let's say there is a method called say hi. So we are just declaring a method in remote interface. So if we are declaring the method in remote interface, it means that the definition should be present in your stateless session bean. So in our case, it is there here. So since it is implementing that remote interface, it is throwing the error to implement that. So let's implement this. See, if you see this, the remote interface method need to be implemented in your stateless session bean. So this is the class, or this is the bean which can be accessed by client. Can be any client, JSP, servlet, or normal Java, that is normal Pojo. Client can be anything. So the client can access these being through remote interface. That is, just now we have created this. Now in order to define this implementation, let's return some string saying hello from stateless session bean. So we are just defining this method. So this is the stateless session bean which says that you have a bean method called say hi, and the signature of that method is there in your remote interface. So all the remote interfaces will be in your client side. So here when we created EJB project, it has been created client as well. So this will be at client side. So client can access the beans in your server through this remote. After this, you need to invoke this from the client. We are done with a remote interface, where the remote interface has a method which has been defined in your stateless session bean. Now here in order to access for the client, you need to provide a name for the bean. So there is a name called map name attribute, inside which you can give the name as hello bean. So this is some name. You can give any name to signify your class. It has to be within this attribute, and this is the stateless bean definition, and this is the remote class. So once these two are done, we need to create a client to access the bean through the remote interface. So let's create a class in this project client, which is a normal Java class. You can give as a client class and then finish. So this is the class having main method, within which we'll try to invoke the remote interface through which we can access the bean definition. So here you need to create a properties object, just because we are trying to locate the bean using JNDI. So that requires the definition or some information like there is an initial context within which we have URL, provider URL. So here it will be the server T3, that T3 is the protocol, localhost, and then port number 7001. This is the port number for WebLogic, and some other information like these are all present inside the initial context. So this is the package from JNDI, which will be used in JNDI in naming concepts. Here you have initial context factory, where we'll pass this string. This is an hard-coded string. You can directly tell it's a weblogic.jndi.wl initial context factory. So these are necessary to connect your JNDI and get the instance of initial context. So once you're done with properties, you can create context, which will be initial context instance, taking this property information. So if you see javax naming dot context, so this is used. This context class will create, bind, and look up your bean. These are all concepts of your JNDI. So it is asking for you to put try catch block. So once you are done with this, you need to look up. So what we are looking is the bean. If you remember, we had given hello bean as a bean name of the session class, stateless session bean class, and it has to follow with hash and complete package of its location. Location should be the location of your remote interface. Let's see what was that interface. Session being remote. So this is how you give a syntax for looking up your stateless session remote. So once you're done, it will return an object of type stateless being remote. You can typecast it and get that instance. So once you have this instance, you can invoke the method. Say hi if you remember. So this method we can put it in a string and then put it in a so that it prints the result. So if you see, this is how you invoke or look up the beans in your server through JNDI concept. And for JNDI lookup, you need these two informations, and using the initial context and context object, you can look up using the method provided by initial context class. And this is the syntax which you need to follow: the bean name and the remote interface location, the complete path of your. So once you are done with, you will be called with the bean method, which will be defined invoking your stateless session bean class. So once you are done with this, you need to do one more task, that is selecting this EJB project client. In properties, go to Java build path. You need to add one jar which is present inside your Oracle, which is the WebLogic location, middleware, WebLogic server, and lib. Inside this lib, there is something called WebLogic tin client. If you see WebLogic tin T3 client and then click OK. This jar needs to be present or else it will throw an error, and that you can put it in your EJB project client. Once you are done with this, you can run the server by selecting this EAR. So you're deploying now your EJB project into your web application server. So run on server. So if you see, this is the application server, and then you're deploying it. And in application server, you always deploy the EAR application EAR file. So once you are finished with it, the server is starting. You see here. So server has been started and it is also in sync with EAR, that is Enterprise Application Project, within which the EJB has been deployed. Now the deployment is done. We can run the client. Client is normal Java class, so you have to run that as Java application. Once you are run with that, so it is giving an error. So this is the error which throws if there is jar missing. But we have added the jar. Let's clean the project and restart it. So server is up. Now you can just run your Java application. So one more thing is you need to, if you go to project client build path, there is something called WebLogic system libraries, which is not required. It comes by default whenever you try to run the project in your WebLogic server. So here we need not require this. So just remove this, and that's the reason it is throwing the error. So the only thing what is required now is WebLogic thin t3 client.jar. So we have done already added along. So just click OK and then restart the server. Server is starting. Server is up. Now let's run this client class, run as Java application. So if you see, it is throwing some other error. Let's see what is that stateless. Oh, can you see there is an error with, here we have given hello bean, but in this the name mat is wrong. So just change it to, save it, and then restart. Now you can just run this client, and here if you see, hello from stateless bean. So we have invoked the session bean class which is there in your remote through remote interface using this JNDI lookup. So this is how it works. Using JNDI lookup, you are just getting the instance of remote interface and calling the bean definition. So this is how you look up and work with EJBs. This is the one way of JNDI. You can also look up the EJB beans. There is another method using @EJB within servlet that we'll see in next demo. So next is the demo on @EJB annotation usage. So this annotation is used to get the bean within the servlet. You can inject the bean or get the bean instance within the servlet or another bean. So let's see the demonstration on this usage. So we have already done with stateless session bean creation. Now in order to show this @EJB annotation how it works, what we'll do is we need to create a dynamic web project because servlets will work on web project. What you have to do, select this enterprise application project which we had already created for earlier stateless demonstration, and then create a dynamic web project. So here you can give project name as web project, and then add the project to an EAR. So this is very important because this is the enterprise application project where the web projects need to be added to EAR. So you have enterprise application app. You need to select this. So whenever we deploy the EJB project, the web project also gets deployed and handled by web container to serve the request. So once you're done with it, finish. If you see, the client, that is web project, has been created. So here we'll create a new servlet. So that will be inside your Java resource source folder. Select the source folder and then say new servlet. So give the package name and class name as. Now here the client is acting as a servlet. So the last demo what we saw, where the Java, that is Pojo, was acting as a client. Here the servlet is acting as a client to access the remote bean, that is stateless session bean, through remote interface. So now we'll say next and then finish. So here we have already defined all the remote interface. So if you recall, we have remote interface within this EJB module, which is the this is the stateless session bean. The remote interface will be within the client itself. So that is there inside this EJB project client. So this is the remote. So since servlet is the web project, we need to create the web project. And here client class was a Pojo. So we added here only. So let's create servlet class which has been created here. Now this is the client class. What we'll do is we'll just close this class, select the servlet. Here what was the remote stateless session remote interface? This was the remote interface. We'll give remote interface bean. So in order to access this without any lookups, you just need to annotate with EJB. So did you see? It has got annotated through this EJB.EJB. So here it is throwing error because you need to add that into this path. For that, select Fix Project Setup. And then OK. So the interface here is being remote. There is nothing as such. If you remember, it is a stateless session being remote. And here you can fix the project setup. So here if you see, it will ask add project EJB project client to the build path of web project. Because in order to show that remote is there within this EJB project client, you need to add it. If you remember, the remote interface is there inside this folder. So just add this project and it will solve the error. This is the only line where you can get your interface, that is remote interface bean, within the servlet or other bean, any other EJB bean using this at EJB notation. There is nothing else, if you see. And now you can use that bean to access the method. So let's print this out from remote interface bean accessing say. So here we'll also say hello from servlet client. So here if you see, this is the usage of EJB. You just need not do anything, just get that project within this build path of dynamic web project and then access the method. This is the method in your stateless session bean. If you see, this is the method in bean remote interface and it has been defined in session bean, that is stateless session bean. So here we are not doing any kind of lookup or any JNDI. You are just using at annotation EJB and then accessing the bean, that is stateless session bean. So now let's run this. First you need to deploy the project. So you're deploying this project because web project is also tagged with this EAR. So whenever you run EJBs, you always need to deploy this enterprise application project, that is EAR. So once server is up, you can run the client to check the result. So this annotation can be used even with any EJB beans. So if you select this client servlet and run on server, so you need to again clean the project. Let's clean it. Stop the server. Now restart. So if you see here, hello from servlet client. So this is coming from servlet. And this is coming from the method which is present in stateless session bean. So this is how you can use the annotation at EJB to call the beans, session beans within your servlet client. So client, as I said, for EJB you can have any client. You can add client even in JSP. You can add client as a JSP, servlet or a Java class. So this is how at the rate EJB works, which is EJB notation. Stateful session beans. A stateful session bean contains a conversational state that is retained across method calls and transactions. Therefore, it maintains a state of the client connected with server. So there is a session between client and server which maintains the state that is retained across any number of calls and transactions done between client and the server. It is having some state which differentiate from the stateless session bean. The state of stateful session bean represents the conversation between the client and the bean. It is like the one-to-one mapping. The @stateful annotation is used to mark the class as stateful session bean. When to use stateful session bean? What the bean wants to hold information about the client across a method invocation, then you have to go for stateful session beans. When the bean works as the mediator between the client and other component of the application, when the bean have to manage the workflow of several other enterprise beans. So in these cases, you have to prefer stateful session beans. Let's see the life cycle of stateful session bean. In this, we see the states like bean does not exist, bean method ready in transaction, that is TX stands for transaction, then passivated. We'll see how these methods will work in the workflow of lifecycle. A session bean instance again life starts when a client obtains a reference to the stateful session bean instance either through dependency injection or through J&DI lookup. Next, the container performs any dependency injection as specified by metadata annotation on the bean class or by deployment descriptor. The container then calls the post construct lifecycle callback interceptor methods for the bean if there are any defined. The container then again returns the session object reference to the client. The instance is now ready for client's business methods. A business method is executed either in a transaction context or with an unspecified transaction context. So in this diagram, you can see that TX method, it means it's a transaction method. If it is non-TX, it means it is not transaction method. Therefore, the non-transactional method is executed while the instance is in method ready state. An invocation of a transactional method causes the instance to be included in a transaction. When the session bean instance is included in a transaction, the container issues the after begin method on it, which means before any business method, and the instance becomes associated with the transaction. If a client attempts to invoke a method on the session object in a different transaction context than the one with which the instance is currently associated, or in an unspecified transaction context, then an error occurs. So, the transaction commit has been requested. The transaction service notices the container of the commit request before actually committing the transaction, and the container issues a before completion on the instance. When the before completion is invoked, the instance should write any cached updates to the database. When the transaction completes, the container issues after completion on the instance, specifying that the status of the completion is either a commit or it can be a rollback. Therefore, while the instance is in passivated state, the container may remove the session object after the expiration of the timeout specified by the deployer. All the object references and handles for the session object become invalid. If client invokes a session object whose session bean instance has been passivated, then the container will activate the instance back. Therefore, from passivate, it can again go back to activate. To activate the session bean instance, the container restores the instance state from secondary storage and involves the post activate method for the instance. The session bean instance is again ready for client methods. When the client calls a business method of a bean that has been designated as a remove method, the container removes pre-destroyed lifecycle callback interceptor method, which will get invoked for the bean instance after remove method completes. This will end our lifecycle, which is shown in the diagram. There can be a commit rollback on the transactions using begin, and after completion, before completion. There are also pre-destroys and post-constructs methods to perform some kind of instructions which can be connecting to the database. And also we have GNDI lookups before connections. So this is the stateful session bean lifecycle. Let's see a demonstration on stateful session bean. We have already created an enterprise application project. We'll use the same project. In EJB project, there is a stateless session bean. So now let's create a stateful session bean. So stateless, stateful, or singleton, all are session beans. So here, give a name as stateful session bean. And then here, if you see that state type, it's given as stateless, stateful, or singleton. So this time we are going to show the stateful. So let's select stateful. And once you're done with, select the remote interface and finish. So this is the bean. So before this, if you see here in project client, it has also created an interface for you, which was nothing but your remote interface. If you see this, we have selected remote, so it has created remote interface. Let's define some method. So the method has been declared in interface. It has to be defined in your session bean as well. So just add that. And say hello from stateful session bean. So if you see, the method has been defined here. Now to access this method, we need to have a client. So you can either use the web project which we just saw in earlier course. You can either access through that, or you can access through the client main class. So let's access it through servlet. Here we'll say now stateful session bean remote. This is stateful remote bean. So here just annotate with EJB. And now instead of using, okay, we'll add one more line in it. Telling this is from so here we are accessed the method which is there in your stateful. Let's So if you want, we can comment this time being and just execute this. So run the project on server, deploy it. You can run the servlet. So here if you see hello from servlet client invoking stateful session bean, and then from that method it is saying hello from stateful session bean. So this is how you have stateful annotated with stateful. That is the difference. Just annotation. Annotate your session bean class using the stateful annotation. And this will complete the demonstration of stateful session bean. The third session bean is singleton session bean, which got added in latest version in EJB 3.1 onwards. The singleton session beans are business objects having a global shared state within a JVM. The @singleton annotation is used to mark the class as singleton session bean. They are instantiated once per application and exit for the lifecycle of the application it will exist. So a singleton session bean is intended to be shared and supports concurrent access by the client. It maintains its state between client invocations. So let's see the life cycle of singleton session bean. So here we have bean does not exist state and bean method ready for pool. A singleton session bean instance also starts its life when the container invokes a new instance method on a session bean class to create a new singleton bean instance. Next, the container performs any dependency injection if required. As I said, dependency injection is used to inject any other bean if required by the current bean, as specified by the metadata annotations on the bean class or by the deployment descriptor. The container then calls the post construct lifecycle callback interceptor to define any methods. The singleton bean instance is now ready to be delegated to business method, call from any client or a call from container to a timeout callback. When the application is shutting down, the container invokes a pre-restore lifecycle callback interceptor methods on the singleton if any. This ends the lifecycle of singleton session bean. JPA, that is Java Persistence API. Java Persistence API provides plain old Java object, standard and object relational mapping for the persisting data among the applications. ORM, it is nothing but a programming technique. That is, object relational mapping is a programming technique which helps in mapping Java object provided in the Java class with the relational database columns or rows or tables. The Java Persistence API contains the following areas. It contains an API, OR mapping metadata, the query language. So Java Persistence API can automatically map your Java objects to and from a relational database by using RDBMS. Entities are the persistent Java objects used to store data in a database. So this is the basic working process of an EJB application using Java Persistence API. Here if you see, there is a client interacting session bean through which the session bean can access many entity beans if required to get the data from the database. So here entities are handled by Java Persistence API through persistence provider. So all these will run under application server. Therefore, any client connecting should connect through session bean itself. They can't connect directly to any of the entity beans. So the entities will work along with Java Persistence API to serve the data or access purpose to return back to the client through session beans. So as told earlier, relational mapping, it's a mechanism or a technique to map the Java objects to the relational database. So here if you see, there is a class called account, and when you create a new instance of account, all the properties called account ID, owner name, balance, everything will be the columns and the rows will be the values of it. This is how the representation is done in tables through OR mapping, that is object relational mapping, which is used in Java Persistence API. So this is how the process carry on. It has the session bean interacting with entity beans through some kind of configuration files or descriptor files like persistence.xml, which is required by Java Persistence API to connect to database. So here it says the persistence.xml need to be placed inside meta inf folder in web project. You have a persistence handling or handled through entity manager factory, which can be done when we create entity manager factory, and then it will process the persistence meta information. So this is the package where the persistence class is obtained. It is used as an entry point for using JPA, that is Java Persistence API. As said, create entity manager factory with the name to retrieve an entity manager factory is used. Then after getting the class requires a file called persistence.xml, which should be present inside the meta inf for any database related informations. It is a required file that describes one or more persistent units. What is persistent unit? It is, as name describes the database connection information by referencing a JNDI defined data source. Entity Manager Factory. An instance of this class provides a way to create Entity Manager, which is required for persistence to work. Entity Manager is the interface in your underlying storage mechanism. It provides methods for persisting, merging, removing, retrieving, and querying objects. There are many API methods in Entity Manager interface you can go through, and also very useful to use those when we work in JPA environment. Persistence context. It is a set of managed entity object instances. Persistent contexts are managed by an entity manager. So these are all the terms which are required when we are working in Java Persistence API. So this is an entity lifecycle where we have a states like does not exist, new, then managed, removed, as well as detached. Let's see how it works. The lifecycle of an entity is managed by an entity manager API. As told earlier, it has got many methods in it. For example, new, remove, find, persist. So all these methods are used to work with database. The entity lifecycle consists of 4 different stages. When new entity, it means the new entity that has never been managed, also called transient. It is by then itself it has been created, and it can also be called as transient. It's a new state. Attached. In this stage, managed by the entity manager. The entity will be in the sync with the database. So whenever it is an attached state, all the entry data or entity data will be in the sync with the database. If it is detached, not managed by the entity manager, but does exist, but it will not guarantee in what state the data it is, because there will be no sync between the database and the entity being. If it is in detached state, removed, the entity will no longer be existing. We also have some JPA specification defining life cycle events for an entity. There is a pre-persist, which says that before entity manager persists an entity instance, then there is a post-persist. After an entity has been persisted, there is a post-load after an entity being loaded by the query, find, or refresh operations. There is pre-update. Before a database update occurs to synchronize an entity instance. There is post-update. After a database update occurs to synchronize an entity instance. We also have pre-remove, which will say that before entity managers removes an entity, post-remove after an entity has been removed. So these are all the lifecycle events of a JPA specification which can occur through JPA operation. We have also entity relations. When we have an entity beans which is mapping to a table, which is nothing but a Java object maps to a table in a database. Suppose we have a class, that is Java class called customer. There is another Java class called address. There is a Java class called order. Then there is a customer. So in this case, you will have many relationships between the tables, or you can call Java objects. So the relationships can be annotated with one to one, many to many, one to many, many to many, and associating the tables through Java objects. So you can have all these relationships even through JPA operations. So here if you see, there is one to one where one customer can have one address, many to one where one order. Many orders can be of one customer, one to many, one customer, and many orders. Many to many customers having many orders. So these are all examples. So the relationship also exists between the entities which are must to have a proper relational database system in an enterprise application. So we have the steps to create entity. First, you have to have a database table. So after which create a JPA entity, which is Java Persistence API entity, which is nothing but a Java class, which is again a plain old Java object. So it is annotated with entity annotation. We do require persistence.xml file inside meta.inf folder to be placed. So as told earlier, which are required for the database informations. And there is another file called ORM, object relational mapping.xml. This is optional. This is not required. If it is required, the information can be split between persistence as well as ORM, but it is generally optional, which we don't use it. Then create stateless session bean interface, and bean that implements the class, implementing the class of that interface. Finally, create a client and then client class with the main method to invoke the interface implementation. So this is the simple steps which are very much simple for getting your entity beans running. So as told earlier, we work along with JPA in EJB to provide a better POJO class entity classes for connecting the database and accessing the results. Following these simple steps, also you can annotate with entity, and many more annotations are also present to identify ID for primary key, table for representing the table. So there are many more annotations which we can see further with some small demonstration. Demo on entity bean using Java Persistence API. So before doing the demonstration, let's do the project setup for Java Persistence API using WebLogic Server. So the demonstration will be shown on WebLogic Server. So there are the setup required. So let's see the setup required. So before the setup, for any kind of Java Persistence API program, there should be JNDI name for Oracle database connection, which we call as data source, need to be set in the server. So here we are using WebLogic Server. So let's see how to do using WebLogic Server to create new data source, which will be the JNDI name for Oracle database connection, and this JNDI name will be used in persistence.xml for database. So this XML file is used for Java Persistence API program. So let's see how to do JNDI data source name. After starting the WebLogic server, which is Oracle WebLogic server, using localhost URL to open up the console, where we have to use localhost :7001 /console/login page to open the login console, that is administration console. Here you have a left panel within which there is something called services, and inside services there is data source. So once you select that data source, you can see I have already created a new data source. So here you can add new data source if you want on selecting this data source. So here I have already added one data source where the JNDI name will be Oracle DS. And if you see the definition, what I have given is nothing but the name, which is nothing but the URL required for the database connectivity. Here is JDBC Oracle thin at localhost 1521 is the port number, and ORCL is the database which I have created to show this demonstration. And finally, the driver is also used, oracle.jdbc.exe.client.oracle.exe data source, which will be the data source JDBC driver class used to create physical database connection in the connection pool. And finally, you need to give the password for your database and the username. So once you have created new data source, you can use this JNDI name in your program. And this is how to create a data source, that is JDBC data source, in WebLogic server using administration console. After doing the data source setting in WebLogic server, so the next step is EJB project. So since we are doing entity bean creation, you have to do within the EJB project. So we have to create EJB project in Eclipse, where new EJB project, type the name of the EJB project, and the Oracle runtime will be the WebLogic server, and select the EJB module version 3.0. 0, which can be more than that. Currently it is 3.2. Click on the OK button and this will create EJB project. Within this EJB project, you have to create session bean because session beans will connect your entity beans. Always there should be session beans to connect your entity beans. Entity beans can't be accessed directly by the client. So here entity bean is created with the help of JPA, Java Persistence API, which can be found in the Eclipse using Eclipse, which gives the option. So before that, the session bean provides the remote interface and session bean file. And in session bean, the business logic is written. So right click on the employee EJB project which we have created and then select new session bean. Once session bean is created, by default the EJB project is not JPA properties. Therefore, user need to add the JPA facet to this project. So how can you do that? Right click on the project, that is EJB project, and then select the properties. So adding JPA facets. Now, once you have selected properties from previous slide, you can select the project facet. So here you have to select even the Java persistence, which is nothing but JPA, and then click OK button. This will add the JPA facet to the project. So here there is persistence.xml and also orm.xml in the meta.inf folder, which will be generated by selecting this project facet. So using the JPA tool, we can create the entity file. So there are many options. You can generate entities from Java class. You can also generate entities from the table. So there will be many options provided to you based on your JPA version. So it's always better to use JPA latest version. So using JPA tool, we can create the entity file. So right click on the project, select the JPA tool and generate entity. This will open up database connection window. So now you will create a database connection. For this, click on the link add connection. So here once you have clicked add, you can select the database. So here we are going to use Oracle database. So you can select Oracle database connection. Then add the database name. So once you select the Oracle database connection, it will give you the driver and also you can give all the details required to connect your database. And once you enter all the details like example provided by host, username, password and port number, you can test the connection. So after which you can select the created new connection. In this case it will be new Oracle database connection. And by selecting the schema for your database, here I've selected Scott. This is the database schema which I'm going to use in this demo. And it will list all the tables which has been created in the schema. So here bank emp is the table which we are going to use. On selecting that table, it will add that Java class into the project. So there will be a Java class generated with getter and setter for all the columns present in this table. So JPA tool, you can very much make use of generating the Java classes from the existing tables and also generating tables from entity beans. Next is persistence.xml. The generated persistence.xml which will be present in meta.inf folder, you can edit that for changing the JTA data source. So we have created the data source in WebLogic server as Oracle DS, and this is the JNDI name which we had created in earlier slide in WebLogic Administration Console. So that JNDI name for your data source of Oracle should be given within the persistence.xml file. Create one dynamic project, which will be the next step, that is creating web client. So after creating a dynamic project, add the name of the web project as the employee client. So you can give the name for your project. And after that, adding the build path. So this project requires EJB files. So since you are connecting your web client with your EJB client, you should also add that EJB jar to your web client. For doing that, go to Java build path by selecting the web client project. Go to Java build path and add the EJB project. In our demonstration, it is employee. So this EJB project should be added in your web client project. So once it is added, you can add in the next step by adding the EJB jar file by exporting it. So select the EJB project, right click and select export to export the EJB jar file. So once you have clicked on EJB jar file to export, you'll come up with this window where you can add the EJB jar file to particular location. So the location will be the EJB jar file will be added to your lib folder, which will be the lib folder of web client. So here web client project in our demonstration is employee client. So within which you have web content, and inside that you have a web INF folder. So lib will have employee.jar. So give this path, so where the EJB jar directly will be exported to this path, and select the Oracle WebLogic server as a runtime. Finally, deploying and running both the projects. Deploy EJB project to the server, deploy web project to the server, and select web project and run on the server. So now these are the steps required to do your project setup. And next we'll see the demonstration after these steps completion, and once these steps are performed, we can see the demonstration on JPA. So we have seen how to create a data source in WebLogic server, that is Oracle WebLogic server. We have also seen the project setup required for this demonstration on entity beans using Java Persistence API. And once we are done with the project setup, let's see the demonstration on JPA. So this is the EJB project which we have created, that is the EJB project employee, and this is the structure of EJB project. And also there is an client project, that is dynamic web project. So you can create by right clicking and selecting new. So this will give you the options for creating dynamic web project as well as EJB project. And this is the structure for your client project, that is web client, and this is for EJB project. So once this is done, the next changes required are, if you see, there is a web.xml deployment descriptor required by the client. So within this client, we have given the employee client, which will be the name of the servlet which we are going to use for this demonstration. So here the client will be the servlet. So therefore, this is the client servlet name, and it has been defined within the web.xml. So instead of defining here, you can also use the @web_servlet annotation for getting your servlet running. So you can do either way, using annotation of @web_servlet or also using deployment descriptor. So either way you can define your servlet name. And here we have used deployment descriptor. And once you are done with this, You have given the path also for your servlet, which is nothing but servlet class, and this will be your URL pattern. And once it is done in web.xml, we'll see what is there inside the EJB project. So in EJB project, after setting JPA facet, you will get persistent.xml generated within the meta-inf file, and this is required by your Java Persistence API. And let's see what is there inside this. We have already seen in the slide the same thing. So after this persistence.xml, we have to give this JNDI name, that is the data source name used for database connection. And in this persistence.xml, there is also class used, that is bankm, and this is the entity bean, and this is the location of that bean. And here there is a provider, persistence provider coming from Eclipse persistent.jpa. So Eclipse gives you the option of creating using JPA tools, and using which we got this persistence XML. And here you have EJB beans within your EJB module folder. So this is the bean which has been stateless, and this is implementing the remote interface. So this remote interface has got all the persistence methods. So here in this interface you have add method, remove method, list, update and find. So these are all the persistence operations. So you can use these operations defined in your remote interface, that is EJB bean, which is acting as a remote interface. And this remote interface is implemented using bank bean, which is nothing but stateless bean. And here it has mapped to the remote bean. And we have persistence context, which will be holding the unit name as employee. So employee is the bean which is entity bean. Now this will be the employee name, which will be a unity, that is unit name of your persistence. And once you've given some name, you can give any name, you can give employee here. And after which you have all the methods present in your interface. So you saw add, remove and get, update. So all these methods you have been implemented in the stateless session bean. So within which you're using an entity manager to get the operations or built-in methods from this entity manager instance. So this is how you can use Java Persistence APIs. So here you can get the method. This is entity manager we have seen. This is Java Persistence API, which will provide you the methods to persist the data into database, to remove the data from the database, and also to get the details by creating a query using the database. You can also update by finding and then updating it. So there is option of find method. So these are all the methods coming from entity manager instance. So you will get this instance initiated by annotating with persistence context, and you have given the unit name as employee. So this is the definition of bean, that is stateless bean. And let's see the entity bean. So this is the entity bean which we are going and talking about. Usage of entity bean, where we are annotating with at entity, and here it has got all the attributes or the properties of the table. So this will be the table name, and within this table there are three columns, that is ID, name and salary. We can see that. So here if you see, this is the table name bank M, and it has got ID, name and salary, and these are the data which are already present inside this table. So once you have seen the details of this entity bean and also the table definition, we can just see the other configuration file. In EJB jar there is nothing, and the required file is persistent.xml, which we have already seen the details in it. And once this has been defined, the another major thing is you should also add a jar file called OJDBC, which is required for JDBC connection. So you need to add in the build path, properties, and Java build path. You can add that JDBC file here. So once it is done, the next step is you have a client file from where servlet, from where we are getting the instance of bean, that is remote bean. So you get the remote instance using the initial context, and within which we look up for the remote bean. So this is the syntax which is used, the remote bean name which has been mapped to, and then the package of it. So within which you can have the instance created, and then the rest will be the operations to show the details on JSP page. So once the instance has been got, it is used for adding, you're calling all the methods where we can see the interface has got many methods: add, get, update, and remove. So here we are adding everything, whatever the data is got from the JSP page using request.get parameter, and once it is got, the values are added to the database through the interface which has been implemented by remote stateless session bean. The same way the details are listed and also found using the methods invoked using the bean. So here if you see, we are calling get to get the details, and find to select the details, and finally remove and update for updating the details. So these are the methods defined in these interface, that is the bean remote interface. So once this is done, you can execute the program by deploying both the projects. You can right click, add and remove, and select EJB project as well as web project, and finish. So once it is published, we can run the JSP page. There is a JSP page which just performs the operation through which the data are displayed. So the action here is servlet class. So here it has got the properties, name, ID, and sal, from which we are getting the data and showing in a JSP page. So it has started. You can right click the JSP page, run on server, so if you see this is the JSP page, that is index.jsp page, which I showed you earlier. You have name, ID, sal, all the three fields properties have been displayed with radio buttons to select appropriate operation for persistence. So here, if you see the result, you can see there are many operations. Accordingly, we have also seen there is a bean remote interface, bank bean remote interface performing all these operations. And the same, it is defined in the bean. So you have find, and then persist, update, as well as delete. You're finding it and then removing it using Entity Manager instance. So we can perform those operations. If you select Find All, it will get the results from the table. So if you see, it has got 2 records. You can also cross-verify from this table. This is the table which we are referring, Bank M. It has got 2 records with ID, name and salary. And we are performing Find All. Therefore, it is showing 2 records. You can also perform other operations, like you can give the ID and click on Find. So it will select the record based on your ID. So this is with the help of Find method from Entity Manager. So same way, you can even add, you can even update and delete. So if you add third record and click OK, it will tell record has been inserted. So this way you can perform all operations in Entity Manager using all the methods provided by Entity Manager instance. And then this demonstration will show you the usage of Entity Bean in EJB. We have used Java persistence with the help of XML file. So if you see the XML file again, here you can do in either way, either by giving a data source or directly defining the properties of data source within the properties tag. So in persistence.xml, you can give all the properties required like JDBC driver, URL, user, password. All these you can give within the properties tag. And this can be used with persistence.xml instead of giving data source. In either way, you can define persistent.xml. So this is how the persistence work in EJB. So we have seen the operations performed, and also we have seen the various methods used in Entity Manager: find, remove and select. And this was a demo on JPA, that is Java Persistence API. EJB query. So, Enterprise Java Beans do have query language, which means the language is used to specify a query over container managed entity bean. The language is similar to structured query language, and EJB query is independent of the beans mapping to a persistent store. We have query API called named query and dynamic query. There are 2 types. So named query. A named query is a predefined query that you create at deployment time. So named queries are stored on the entity managers. So basically named queries are predefined queries that you can create at deployment time, which is very important to note. It is created at deployment time and those are stored in entity manager. We have dynamic query, which is a query object which is dynamically created at runtime by using entity manager method like create query or create native query and many more. So if you see, the persistence query language can have statements and clauses just like SQL, If we are aware of SQL, knowing this will also be very simple. It is simple as structured query language. We have statements and clauses which will include select, update, delete, from, where, group, all kind of clauses, having order by, ascending, descending. We also have joins for inner, outer, left and fetch, conditionals and operators. So there are many conditions and operators. Also distinct, object, null, true or false, not, and, or, between. So all these are conditions and operators which can be used in your query for any kind of conditions. We also do have built-in functions like average for calculating the average, max for maximum, min for minimum, summing the total, the count, upper for uppercase, lower for lowercase, trim and position and many more. We do even have the current time or current date for handling the date or timestamp. An example if you want to see in select, if there is the category table, then you have to have an alias for it as C. And this is the basic syntax or example for Java persistence query language, which you can see, which will include all the clauses as well as the operators and conditions. So if you see in this query, it is very simple. There are many queries defining with different inclusion of the words which are given by JPQL, which are very much similar to structured query language. So those who are aware of structured query language, this will be very easy to work with. And there is an even update and delete also given, where you can update and also delete. And it also has aliases for each SQL or JPQL statements. So the basic step for JPA query using JPQL are obtain an instance of an entity manager, create a query instance, execute the query, retrieve the result. So if you see there is no connection established statement at all, that is the best or advantage of this Java persistence query language. You need not have any statements connecting to your database because all those are taken care by the container itself. You just need to invoke or create an instance of entity manager and then a query instance and also use the methods available in entity manager. As discussed earlier, we have find method, persist method, remove method. So all these methods can be used for performing the operations and then finally execute the result and retrieve the result. These are the simple steps for any JPA query language which can be used in Java persistence query language along with entity beans. EJB container services. We have seen so far talking about container services, EJB. The main advantage of going for EJB is the containers itself providing default services. That is the major advantage for EJB to work with. So the EJB container present within the application servers will provide the services for all its beans, which are beans are nothing but Java classes. So any kind of Java beans deployed, the EJB container will take care with its own default services and will just look the services normally provided by EJB container. Dependency injection. As said earlier, dependency injection is also a concept or mechanism which will inject the beans required within the current bean. It will inject on fly using the annotations. Concurrency. It is also one of the concepts in database which you have to have concurrency in maintaining the data, which is also taken care by container. We have instance pooling. So the pooling and caching, which are nothing but these are required for connection poolings, so which are again handled by container. There are transactions, which we are going to see in more detail. What are these transaction which will ensure our application state maintains its integrity. So, to maintain the data integrity, transactions are very much useful. So, we'll see in more detail. Security, it is also one of the major advantage. The security is also provided within the container. Timers, the timer service allows the EJB container to fire time-based events into business logic methods. So therefore, instead of servicing a client request, we may instead set triggers. So you can set timer service and set the triggers to act upon. So for instance, process or a batch job every hour. Naming and object stores. Interoperability. Lifecycle callbacks. We have seen many lifecycle callbacks so far, which container will handle like pre-construct, post-construct, this pre-destroy, interceptors. These are very generic utility for defining your own application logic to be applied in a cross-cutting manner. So interceptors are also very useful concept where you can have your own generic. The term generic is important, which can be applied for any number of beans all over. So you can use these interrupters for all cross-cutting manners like logging or connections, which can be applied before and after bean execution. This is a powerful way to promote code reuse, and therefore it's built in into the platform. We even do have platform integration. Next, we have transactions. As I said, this is also one of the important feature which container provides for EJB beans. So this transactions can be handled in there are many ways. We'll see all those. What are transactions? Transactions control the concurrent access of data by multiple programs. So in the event of system failure, you have transactions ensure that after data recovery, the data will be in a consistent state. So this is very important. Transactions are very useful to maintain the consistent state of an object. There should be a sync between the application data and the data inside your database. To maintain that, transaction will control all the concurrent accesses of the database or data by multiple programs of clients, which we call as. So, for example, if you want to consider a business transaction, any simple application, a programmer can need some of the steps. For example, consider you have a banking transaction, which will begin the transaction, debit checking account, credit saving accounts, and update history log. So these are all set of operations done by the program. Finally, you need to commit or rollback. So this is set of instruction being executed before commit or rollback. This is how the transactions are useful to maintain the consistent state. Each transaction will ensure asset, which is normally called as, it is nothing but atomicity, consistency, integrity, and durability. So this is very important. Transaction will ensure all of these properties. There are two types of transaction, as I said earlier. In EJB, we have container managed transactions and bean managed transactions. The container managed transactions, in this, the EJB container sets the boundaries of the transaction. So the container itself will manage the beans. The bean transactions are managed by the container itself. It will set the boundaries on the beans. So here if you see, this is the container managed transaction. As I said, if there is a bean 1, that is Java class bean 1, which is having a method A, and within the method it is trying to create a transaction and invoke a transaction by calling method B. So these are the scopes of transaction. So when method A starts a transaction and invokes another method B, then the transaction attributes are required to be set. So we have transaction attributes which work and necessary for container managed transaction to signify what it wants. Suppose there are attributes like required, requires, new, mandatory, not supported, supports, and never. Where if you consider required attribute, in this scenario, if the client is running within a transaction and then invokes the enterprise bean method, the method executes within the client transaction, and if client is not associated with any of the transaction, the container starts a new transaction before running the method. So here if you see, if you set the attribute as required, then the container itself will create a new transaction if there are no transaction existing for the client. And the required attribute is the implicit transaction attribute for an enterprise bean method running with container managed transaction. You typically do not set this. You need to override another transaction attribute because these are declarative. You can easily change them anytime. We do have requires new. So this attribute says that if a client is running within a transaction and invokes the enterprise bean method, the container takes the following steps like suspends the client transaction, starts a new transaction, delegates the call to a method, and then resumes the client transaction after the method completes. So here if you see in the same diagram, if you try to do requires new as an attribute, then what it does is, if the client is already having a transaction running, then if you set this attribute requires new, then what will it do is it will suspend the client transaction. Then it will create the new transaction and then run inside that transaction. The method will be executed within the transaction in the new transaction. And once it is done executing, then it will resume the client's transaction which was suspended. This happens when it is requires new. If it is a mandatory attribute, then it says that if a client is running within a transaction and invokes the enterprise beans method, the method executes within the client transaction. If the client is not associated with a transaction, the container will throw a transaction required exception because it is mandatory for a client to be running with a transaction. So this attribute says it is mandatory. If it is not, it will throw transaction required exception. Not supported attribute, if the client running within the transaction and invokes the enterprise bean method, the container suspends the client's transaction before invoking the method. So therefore here it is not supported. So as it says, it will suspend the client transaction before invoking the method. And after the method has completed, the container will resume the client transaction back. So these are all the attributes to act and give the directions for the container managed beans. So based on this attribute, the container will act upon. We also do have supports. It means if a client is running within a transaction and invokes the enterprise beans method, the method executes within that client transaction. If the client is not associated with any transaction, then the container does not start any new transaction. It means it just supports. If you have transaction clients, okay, it will run it. If you don't have, it will not create new. In turn, it will run the method. So it is not mandatory to have transaction. It will just support if you have one. Then never attribute. If the client is running within a transaction and invokes the enterprise bean method, the container throws a remote exception because the attribute is never. It means there should not be any container transaction for this method. The never attribute says that. So if the client is not associated with a transaction, the container does not start a new transaction before running the method. So these are all the attributes which are very much important when you're handling your beans through container managed transactions. So for container to give the directions, you need to give all these attributes. Next, the second type of managed transaction is bean managed transaction. So here, the bean managed transaction demarcation, the code in the session, it itself demarks the code or within the bean, which can be a session bean or a message driven bean, explicitly marks the boundaries of the transaction. So here the container is not marking the boundary, whereas the bean itself is marking the boundary for itself. The bean can be anything. It itself will mark the boundary when to commit, when to roll back. We'll just see the small snippet. Here if you see, this is the Java snippet within the Java bean, which says you yourself will tell begin transaction, and based on certain condition you will commit the transaction, and again if there is some condition you will again update or perform any kind of select operations and finally commit or roll back. So basically we are seeing bean managed and container managed, where it is very straightforward. Bean managed, that is, the programmer itself will code through the entity beans and marks the demarcation. And if it is container managed, the container will take care of managing the transactions. And finally, we have a transaction timeout, which says for any container managed transaction, you can use the administration console to configure the transaction timeout interval. So here, if it is container managed transaction, there is an admin console which can be present in every application server. So using the server, we can configure the transaction timeout interval what you want. You can select within the administration console. So as said earlier, EJB container will run within the JEE application server. So you can set it using administration console. If it is the enterprise being managed, which is nothing but Java transaction API transactions, then you invoke the set transaction timeout method of the user transaction interface. So this is how if you go with enterprise being managed transaction. So being managed transaction, as said earlier, we have a Java transaction API that is controlled by Java Enterprise Edition Transaction Manager. So to demarcate a JTA transaction, you invoke the begin, commit and rollback methods of the transaction which is from user transaction interface. So here we'll come to the end of EJB, where we have covered the transaction, we have covered the types of session beans. We do have entity beans, which are in terms of entities in Java Persistence API. And we have annotations with simple programming, where we normally have only POJOs. You need not have any interfaces or classes to extend. So the EJB has got many advanced features for any kind of complex enterprise applications. So there are many advanced features which are coming further in further releases. We do have 3.2 with additional features. There is a features called optional interface, so which is coming from @EJB. So all these we can explore by seeing the current version features, which are very important to know when we are developing enterprise application. Thank you.